Welcome! So, we've all seen the headlines about these incredible machine learning models. But here's the thing, there's this huge, invisible wall between building a cool model in a lab and actually making it work out there in the real world. And that gap, well, it's one of the biggest challenges in AI today. And it's exactly the puzzle that MLOps is here to solve.
In this question, this is what kicked the whole thing off. It was asked at this event called O'Reilly Foo Camp, and it basically became the inspiration for the book Practical MLOps. It just cuts right to the chase. With all this amazing tech, why is it still so painfully slow to get real value out of machine learning? As we're about to see, the answer has a lot less to do with code and a whole lot more to do with culture.
So to really get the solution, we first have to wrap our heads around the problem. And at its heart, it's this fundamental clash between two completely different worlds, each playing by a totally different set of rules.
Yeah, on one side, you've got the data science world. It's all about research, running experiments, and that thrill of discovery. But on the other side, you've got ML engineering, and they're focused on things like reliability, scale, and, return on investment. It's the lab versus the factory floor. And this is the gap where so many machine learning projects just fall apart.
Now check this out, because this slide really shows you the economic reality of the problem. Just look at these job numbers from late 2020. The demand for data engineers and machine learning engineers, the folks who actually solve this production problem, it absolutely dwarfs the demand for data scientists. Businesses are basically screaming for people who can make these models work and deliver actual value.
So how do we bridge this gap? Well, the answer isn't some new piece of software. It's a complete shift in how we think about the problem. And to really understand this shift, the authors share some pretty powerful lessons, learned not in a server room, but out in the real world.
First up, co-author Alfredo Deza talks about his time as a professional athlete. He says keeping fit is just like MLOps. If you miss a workout, you're not just standing still, you're actively losing ground. It's like letting a wheelbarrow roll all the way back down a hill. And a model in production that isn't constantly being looked after, that's your wheelbarrow, and it is sliding downhill fast.
And this was his actual strategy for training while he was injured. Assess, adapt, look at the long-term trends, and double down on what works. Sound familiar? It absolutely should. This is a perfect playbook for monitoring a machine learning model. It's this continuous, high-frequency loop of checking in and making adjustments. You just can't launch it and forget it.
All right, now for our second analogy. Co-author Noah Giff's background in Brazilian Jiu-Jitsu gives us this really powerful idea: the gym versus the street fight. You can practice and perfect a technique in the controlled, predictable environment of the gym, but that same move can be completely useless in the chaos of a real fight.
And this slide just nails the point. A model that's built with clean, perfect, curated data? That's like training in the gym. Production? Well, that's the street fight. It's messy, the data drifts, and what users do is totally unpredictable. MLOps, then, is all about building models that can actually win in the real world.
Okay, so we have the mindset, continuous assessment, built for the messy real world. Now let's look at how we turn that philosophy into some real actionable principles.
I absolutely love this analogy. Think of a big cloud provider like AWS as being a lot like Costco. You can walk in and buy a pre-made pizza, right? That's a grab-and-go solution, kind of like a high-level AI service. Or you can buy all the raw ingredients, the flour, the yeast, the oil, and build your own meal from scratch. And that's like using foundational services like EC2 and S3.
And making that choice is super strategic. The principle of comparative advantage basically tells us to focus our energy on what makes our product special. Why spend all your time building an oven from scratch when you can just buy the pizza? Don't waste your energy rebuilding infrastructure that the cloud providers have already perfected. Use their pre-made stuff so you can focus on creating your own unique restaurant.
The next principle is something called Kaizen, which is this Japanese philosophy of continuous improvement. This connects right back to that athlete's mindset of checking in every single day. It's all about creating these super fast feedback loops for small, tiny improvements, all based on a realistic, data-driven look at how your system is actually performing.
Now, a huge part of MLOps is automation. But here's the twist. The goal is not to engineer humans out of the process. It's actually the exact opposite. It's to create this powerful partnership between automated systems and human insight.
This is one of my favorite examples, hands down. So, back when chess programs got strong enough to beat any human grandmaster, something incredible happened. The best chess player on the planet was no longer a human,
And it wasn't a computer, it was a human-computer team, a centaur. An expert human using the software as a tool could consistently beat the software by itself. That is the future of MLOps.
And we see this partnership in action right now with AutoML tools, like Apple's Create ML. You can literally just drag and drop a dataset, train a super sophisticated model, and test it out in seconds. This kind of automation doesn't replace the expert, it empowers them. It frees them up from all the repetitive stuff so they can focus on the bigger picture.
Which brings us to our final and maybe most important section. Because after all the tools and the pipelines and the principles are in place, success in MLOps really comes down to the human element. It comes down to culture.
The authors argue that to do MLOps right, you need to cultivate these intellectual virtues. Humility, to recognize that your model isn't perfect. Courage, to challenge your own assumptions when the data proves you wrong. And empathy, to really truly understand the problem you're trying to solve. You see, this isn't just about technical skills, it's about a culture of critical thinking and deep collaboration.
And that brings us to one final thought that just wraps everything up. In martial arts, a good instructor doesn't hand out a black belt for knowing theories. There's only one question that really matters. Can the student throw the punch? And for all of our complex models and elegant pipelines, the same thing holds true. The only question that matters is, does it actually work in the real world?